Hey guys, today I'm going to be looking at building a wireless monitoring system for my solar power generator. Now, the reason why I want to do this is my solar generator sits out in the garage, so if I want to go and check voltage on that, I have to go out there and look at it. So I just want to be able to monitor it constantly from inside the house, which normally doesn't seem like something that's all that useful until you actually get into a power outage and you need to be able to monitor how much voltage your batteries are at and be able to watch that. So anyway, that's why I've set this up. This is the receiver. Ignore all this stuff, that's completely unrelated to it, but there's nothing really on here but wires and that little potentiometer for the contrast adjust on the LCD there. But this is just using an Arduino Nano. The reason why I chose the Nanos is because those have a 3.3 volt output pin on them instead of the Pro Micros, which don't have a 3.3 volt pin on them. And then we've got a little NRF24L01 module here. I've done a video on how to set these things up, so I'll go ahead and link that in. But anyway, this part is being powered off an old cell phone battery. Now, one little thing with powering these LCD screens straight off of a battery here, because I don't really want to implement a boost converter or anything like that, is the fact that as the voltage drops, the contrast of the LCD will drop. And I'm just going to leave it like that because that kind of serves as a low battery indicator. Without having to do any kind of actual low battery indication. But right now you'll see it's flicking between the actual numbers and signal lost. I think if I actually optimize where these antennas are pointed and where they're at, it would probably work a little bit better. And also I need to optimize the code so it's not going into that signal lost so quickly. You see it flicking in and out of that really quite quickly. But when it does get a signal there, or if I stand in the right spot, mind you, where I'm at in this house, this is about as far away as I can get from that solar generator, which is on the other side of the garage, which is way over on the other side of the house. So this is about as far away as I'll ever need to have it work. And you see it is kind of coming through there with the signal, but if you can't see that, it's displaying volts, amps, and watts. So anyhow, let's go ahead and take a look at the transmitter, which is outside, and then we're going to start putting together the circuitry. And then in part 2 of this video, we're going to build cases for the transmitter and the receiver. So anyway, let's go and take a look at the transmitter. Alright, so this is the transmitter unit here, which pretty much just takes the place of this little watt meter, which I already had in here, so I've just had to drop this in here. Of course, I'm going to make permanent circuit boards and whatnot for this, but anyway, coming off the solar charge controller over here, we're going through the XT60 connector, which goes through this, and this module right here is a Hall effect current sensor, which will read positive and negative 30 amps, and 30 amps is what this charge controller is rated for, so that's why I've chosen that. And this other connector just goes off underneath here into the batteries. So anyway, on this board we have that little Hall effect current sensor module and 2 resistors. The resistors set up a divider for the Arduino here, since you can't put 12 volts straight onto one of the analog input pins. I'm dividing that by 10, so theoretically you could actually put this on a system that goes up to 50 volts, but anyway, that is just your Arduino Nano up there, and then the NRF24L01 Plus board on the other end of that. So that's all there is to the transmitter unit. I'm going to go ahead and take this stuff inside, and we'll go ahead and start making actual circuit boards for this, or perf board prototypes. But anyway, I'll go ahead and start making something a little bit more permanent than a breadboard. Alright, so I'm going to go ahead and start with the transmitter unit, and I've got these pieces of perf board that I'm going to use. Might be able to cut one of these in half actually for the transmitter, but I'm kind of planning on going ahead and putting everything here in sockets except for the resistors. I'm just going to solder those straight on, but I'll probably put the Arduino Nano in a socket, like just these pin header type things. Make it easier to remove if I ever need to. And then I'll put this little current sensor module in a socket too. And I also want to put this in such a way that I can actually get to the USB port from the inside or from the outside of it, because eventually this is going to go into a case. But yeah, I'm going to go ahead and start building this. I'll get a time lapse of it and see where this goes. So this is the completed transmitter unit here. The wiring's pretty ugly looking on the thing, but so far from the tests that I've conducted, it does seem to work. And you see some of the wiring in there, but anyway, this will be the first test of it on 12 volts, powering itself on 12 volts. I hooked it up through USB once already just to see if that would power it, and it does. So hopefully this doesn't throw a whole bunch of sparks. Yeah. Looks like it works just fine, and the receiver unit started displaying the voltage over here. 11.62 volts. The amperage is kind of jittery. I might have to recalibrate that, but the other thing, I do have to figure out which way this has to go for the solar power system, because it might be reading negative if I leave it like this. But I'll have to go and take this outside and look at it, and we'll see. Actually, I'll just go set that up outside right now, and we'll see if we can still get signal from in here. Alright, so it looks like the same thing. It's still at least trying to get a signal. Oh yeah, there we go. If I hold the thing up in the air so that the antenna is flat, like this, so it's flat, it actually seems to get much better signal than if I actually point the antenna at it, so that's kind of interesting. But it looks like we're set up right. We're getting the 0.47 amps or so. I still need to redo the code so it doesn't pop up with that signal lost so easily. It's doing it kind of quick, so actually if I reset this thing, you'll see we're already on version 1.2 or something like that. Yeah, but anyway, transmitter unit is working. Now I've got to go and make the receiver unit for this thing, so that should be well, about the same process, except for this will have to have an LCD on it and some extra wiring. So anyhow, I'll get to work on that. set up here. It's all soldered together. Hopefully it works. Got to replace this Arduino Nano and this board with the ones that I've got over here. You can kind of see the mess of wiring again. It's always pretty bad really this time, but pull that off too. You can see all the wires that are underneath that. And these headers are a little bit long on this LCD screen, but that's okay because it raises it above everything else. Because this is going to have to stick through like the front of the case, so that's alright to me. That's a little bit higher. So that plugs in, not quite like that. But we've got the programmed Arduino Nano there, and this one, this little NRF board, because that's got the capacitor on it, should work a little bit better. And if we turn this on, let's see if something interesting happens. Now the contrast adjustment potentiometer is underneath the LCD too, so I'm not real sure. I may have to turn that up. Then again, it might not be hooked up right either. Nothing. Felt like that pot was turned all the way over. Turn it all the way the other way and see what happens. This should be a completely white screen. Oh yeah, we've got something in there. If I reset this maybe. Yeah, I have a feeling something isn't quite wired correctly. Contrast is actually all the way up on that display too. Yeah, because we're kind of getting a jumbled mess on that screen. I'm not real sure what's going on there. Alright, so the screen isn't working, but from the looks of what I can see here, it actually seems like we are getting a signal from that. Every once in a while you see it pop up with a different screen. So, actually if I hold it up here, it does it. Looks like that. Different screen. And then you see the no signal thing flashing. So, I've got a feeling my wiring is off probably by 1 or something on this LCD. But other than that, it's actually working fairly well. Alright, so that was a relatively easy fix. There's just a little piece of solder between data pin 2 and well, it was data pin 2 and 3 on the Arduino there, which was pins D7 and D6 on here, and that was messing with our data. I'm getting some kind of signal there, but it doesn't look like the right one. Actually, I might have to go take this outside and see what it's doing, because I see negative 40 amps, and that's a sign that this NRF thing isn't hooked up right. If I pull this out, watch what happens. Actually, maybe it's not going to do it the way that I thought it would. Initializing version 1.2 signal lost. Okay, so there may be... Yeah, see that negative 40 amps? That's not right. Something's probably off with this too. Oops. Simple problem. I forgot to put the wire between pin 12 on the Arduino over to pin 7 on the little NRF chip. So anyway, let's put everything back in here, see if it works now. And it should, hopefully, work. That goes in here. This one goes in here. And we're going to take a guess and say this is the right Arduino. I've got one that's not programmed floating around here, and I've got the one that is. Won't take long to figure out. Yeah, that's the right one. Signal lost, or is it just because we don't actually have signal? Let's try to get something. Hold up to the sky. There we go. 13.5 volts. Yeah, it doesn't get very good reception. I'm going to have to modify some things in this to at least make it think that it has better reception with the code. Anyway, I'm going to change one more thing. I'm going to mess with the code, and then I'm going to start working on building the case for this thing, and that will be about it. So anyway, I'm going to modify the code a little bit. I'll see you in a bit. Hopefully I can get this signal just a little bit better, or at least make it look like it's a little bit better. So anyhow, I'll see you once I modify that. Alright then, the code has been updated. Let's see what we get here. Version 1.3, no guarantees we're actually going to get a signal at this part of the house, of course, though it was earlier. You notice it will take a lot longer now. It's probably not getting a signal. The thing will go for up to 25 seconds trying to find one. Either that or it is kind of attempting to find a signal. It is finding one every once in a while. Because the way the code works on this is it takes averages. It takes 20 averages to be exact, and it's supposed to take 20 averages in about a second or two. That, of course, would be if you had perfect signal. The far end of the house here, we're taking 20 averages over the amount of time of like 10 seconds or however much time it takes to get signal. So we're giving it quite a bit of time in order to be able to take those averages, basically. Like I said, 25 seconds is the timeout on it now. But you can see it is working. Alright, there you go. There's a timeout. Signal lost. And really, if I don't stand in front of it here, and as I said, this is as far away as the thing will ever be. And as soon as I picked it up there, it popped right back into this mode, so it actually got that 20 averages in a second or two as soon as I picked it up. But so anyway, it is struggling a little bit to get a signal over here, but simple 1602 LCD display, NRF24L01 module, and an Arduino Nano. That's all this receiver is. Power switch is actually a TP4056 board underneath this too, in order to charge this battery. So anyhow, I'll probably experiment with this a little bit more, but I'm going to start designing the case, and you'll see that in part 2 of this video. So anyhow, hope you enjoyed this little video. See you next time, guys. Bye.